much for the invitation. Let me first introduce our first resources person, Engineer Professor Udayanga Hemapala. Engineer Professor Udayanga Hemapala graduated from Faculty of Engineering, University of Moratuwa with BSc Engineering honor degree, specialized in electrical engineering with the first class in 2004. Also, he was offered his PhD from the University of Genoa, Italy in 2009. He's a chartered engineer and a member of the Institution of Engineers Sri Lanka, and also he is a member of IEEE of US. After contributing as a senior lecturer for several years, he was promoted to the post of professor at the Department of Electrical Engineering with effect from 2017, and currently he is serving as the head of the department. He was a council member during the session 2018 and 19, also 2019 to 20, and currently he is the honorary secretary to the council. Also, he is an active member of the Education Committee and Accreditation Board of IESL since 2019. Moreover, he is a coordinator of the Smart Grid Research Lab, which was recently established with the university premises, and the representative of the University of Moratuwa for the microgrid pilot project funded by Asian Development Bank. Professor Udayanga, over to you, sir.
Thank you very much for the introduction. I hope you can hear me, right?
Check one, check one.
Thank you very much. I hope you can hear me well. Right. And I'm Udayanga Hemapala, head of the Department of Electrical Engineering, and the topic will be basically microgrids and applications. applications, but even though microgrids and applications, I start from the beginning because this is the first presentation. Now, as you already know, the conventional power system is basically maybe starting from the big power plants like coal power plant or maybe hydro power plants, and then transmit the power to the load centers through a transmission system. Then when it comes to the load centers, maybe even low voltage, then even the customers through a low voltage network. That is the basic concepts we had. Then what was happened basically with the introduction of renewable energy, then people started to feed energy from the load centers as well. Then all these technical issues started to come to this picture, and then people started to discuss, I mean, how we can connect the solar cell, the renewable energy, or equal as distributed generations, and what are the technical issues, then how can we solve these issues. Then with that, as you know, generation, transmission, and distribution, then what are the problems associated with these conventional power systems? Because these are bulk generation, right, and generate at then because our generate is coming from a bulk generation, then if there is some issue or any failures, then it becomes like cascading failures will happen. Then heavy reliance on fossil fuels. These are the basic issues. Then this renewable energy came to the picture. Then we started to discuss about distributed generations. Now, what are the distributed generations? Means distributed generation refers to a variety of technologies that generate electricity at or near where it will be used, right? Like maybe wind power, or even it can be a small diesel generator, or even it can be a battery, or it can be a solar system. Then we call those as distributed generation because these generations are connected at every point of the whole grid, and as well as they are connected into the low voltage network. Then what are the advantages? As we know that energy cost saving and reductions of transmission and distribution losses, and encourage the renewable generations because of the advantage we are getting. And finally, uninterrupted power supply to the local loads through proper integration of DG units, that is distributed generation units, in case of utility grid failure, because we are connecting all DGs, but if the grid fails, and even then we cannot get the power from the distributed generation, then people start to think that this is useless, because we get the electricity from the grid and we generate the energy from the distributed generation, but whenever the grid fails, you cannot get the energy from the DG as well. As well as then when we introduce this solar or even this distributed generation, we had some scheme. I hope other speakers also will discuss that. Then it started with net metering and net accounting. Both are same. Basically, you are getting a 1 meter, and your generations will count according to the whether it is net metering or net accounting. But finally, it's the electrical connection is same. Then when it comes to the net plus scheme, it's a little bit different. You are having two the metering, and when you import, you will get, you have to pay, and when you export, you will get the money back. Then all these three scenarios, we are using an inverter, we call it as a grid tied inverter. Grid tied inverter requires voltage and the frequency reference, which is provided by the grid. Because without the grid, you cannot operate the inverter, because that every inverter should have a reference that is for the voltage and the frequency, and that reference is coming from the grid. If you can make that reference by yourself without the grid, then that's the point where you can make it or you can use your own electricity even without the grid. That's the other the technical or the research. All I mean, these problems came after that, and the people start to think how we can get the solar energy even without the grid phase. With that, then I think some 2 or 3 years ago, 2020, this hybrid inverter concepts came to the picture. And according to the, if you go through the Sri Lanka standard, there are two types of inverters given, I mean, according to the definition, type 1 and type 2. The type 1 is grid connected solar hybrid inverter, and the type 2 is grid interactive solar hybrid inverter. Basically, these hybrid inverters, different people define the hybrid the definition is different ways. According to the Sri Lanka standard, there are two types, that is grid connected one as well as the grid interactive one. But if you search through the internet, you can find several other definitions as well. Then if you look at, I mean, if you are going to buy an inverter, or if you are going to use a hybrid inverter, try to understand what is the meaning given by the supply. Because different people use hybrid, even sometimes having AC DC is hybrid, right? It's also hybrid because you have the AC and DC. Like there are different people. Some people may say, okay, it's also hybrid, but you have to read their project or at least their specifications to understand whether they are giving a real solution or real solution for your requirement. Now, if you look at this type 1 and type 2 inverters, they are incorporated with batteries to store your excess solar energy and allows use of stored solar energy during peak times, according to their definition, and known as self-use and self-consumption or load shifting. But only type 2 allows you to use in the grid interactive mode, where inverter can provide the electricity to essential during the blackout. In the type 1, you cannot do. Right, type 1, type 2, you can give the electricity to the during blackout only for maybe important loads. Right. Then, if you go through the internet, there are different companies available giving these hybrid solutions. I'm not going to go into details, but if you just look at the first one I have taken from the ABP, and you can see according to their solution, you can get I mean, you can feed the electricity to the grid as well, and when the power failure is there, then you can give the electricity to your important loads, like backup only loads. That means you have to define what are the important loads, and then you have to rewire, because you cannot, because when you cannot connect all the loads, you have to rewire for the important loads. Then there are solutions like that as well. Then you can reduce the cost, because otherwise you have to size your battery size according to your whole load. If there are any important loads, then you can reduce your the battery size, but then you have to have a different maybe wiring system, or otherwise you should know how to use it during the blackout. That is one of the hybrid solution. And the Fronius system is there. I mean, there even you can connect the pin system as well. That is also hybrid system. I mean, you can have your own pin system as well as solar system, and also it can power to the whole loads as well. And that solution is also there. It's also called as hybrid. Now I will go to what what I'm trying to explain is what is the meaning of the microgrid, but because otherwise people think that microgrid is also something like a hybrid solution. Now, what are the limitations of hybrid solutions? sometimes you cannot integrate several sources. Even Fronius one, there are two. I mean, even you can connect the solar system as well as you can connect the wind system, but you cannot connect the EG into the same system. There is diesel generation. Now, integration of several customers. If you take a hybrid system, I'm assuming your house is there, you can have your own hybrid system, and as if there is another house nearby, and they have to buy another hybrid system. There is no way of connecting these two houses together. Then it becomes another something like a grid. There is also that limitation is also there. Then flexibility is not there because most of the hybrid systems there are maybe 1 or 2, 3 modes are available. Then you have to select which mode is preferred. But the customer cannot ask, I need this kind of operations, like whether I have to get the electricity from the grid for charging, or whenever discharging, when I have to discharge, all the those requirement you cannot give. But if there are predefined modes, then you can ask the customer, ask from the supplier to maybe prioritize these modes. Other than that, the flexibility is witness the hybrid solution. Then increase. If you want to increase it to maybe, I don't know, I mean, according to my understanding, maybe you can go for 100 kilowatt, not more than, because I search through the internet, find hybrid systems, this kind of 175, 200 kilowatts. Right? Maybe in future will come, I don't know. Right? Then if you want to increase the size of the system, then that is also a limitation in the hybrid system. Right. Then what is the micro? Now, to look at all these systems, like whether it is off-grid, whether it's a grid-connected systems, there are some limitations, and as I explained to you, then microgrid is a concept came as a solution to those problems. Now, if you look at this picture, you can see it's basically a hybrid system because you have the solar system, they are right, and the loads are there. Then the difference between the previously shown hybrid systems or the off-grid systems, here the flexibility is there, right? And as well as you can increase your size, you can connect more solar systems, or you can connect more loads to the same system, and you can increase the system. It's like a small size of a bigger grid, right? That's why we call it as the microgrid. And the main heart of the micro, because if you look at all other components are similar to the hybrid system. What is the main heart? Main heart is the central control. And if you are going to buy a microgrid and install somewhere, all other systems are same. Therefore, even you can find a local supplier or local contractors to do all these other things. But only problem is to find the microgrid central controller, because locally you cannot manufacture that microgrid central controller. You have to ask from some other manufacturers. There is the manufacturers or the suppliers, the microgrid industry. They are the only people who so cost, even though it's not because if you look at microgrid central controller, it's not a bigger one, very small one, but it's very costly because they have invested for the research and everything for that. And otherwise, if you look at just the cost component of the cost, it's very small. But there are a lot of money for the central control because it's the heart of the microgrid. This I am showing a simple example. That is a microgrid central controller we have in the University of Moratuwa. And this is the main controller. It's the heart and the brain of the microgrid system. And this is by the EETESC, that's a German company. And it's basically showing, it's like a SCADA system. As you know, SCADA system in the CV or the main grid. It's like a same SCADA system, but a smaller version. And main control is controlling the microgrid with the diesel generator, battery energy systems, PV, wind, and as well as grid synchronization, because you already know most of you are maybe electrical engineers. Then if you are connecting something into the grid, you have to synchronize. And all these and synchronization and desynchronization, right? Both Therefore, I mean, this is the main heart of the microgrid, and it's, I mean, we cannot develop ourselves because it's still, it's, I mean, we cannot even, I mean, when we got this microgrid, we try to understand, I mean, we try to remove these things and see what's happening, but it's difficult, because they are not giving all this information, even at least they are not giving these algorithms and all these things. And microgrid, if you take the characteristic, because it's a local one and it's an independent one, as well as the intelligent is there. Right, there are modes of operations, as I explained previously. There are grid connected mode. Then basically what they are doing is that microgrid central controller. So that is, there is a switch we call static switch. We can close this switch and then feed the loads from the main grid, or what maybe from the diesel generator, or what from the solar system, or maybe the battery systems, depending on your requirement or your basically from your algorithm. And then when the grid is not available, then we call it as the island. Then during that time, the grid is not available, then this switch is open, then microgrid does not follow the frequency and the voltage variation of the grid. Then it is a island situation, and then the main problem is coming, because as you know that when a system is not connected to the grid, but still you have to control the voltage and the frequency. Then your microgrid should have the capability to control the voltage and the frequency. Then that part is done by the microgrid central control. Right, and these are some of the examples of operating modes of the system. Now, as I explained previously, there are modes, but these modes actually you can program and you can request from the supplier, because it's an algorithm is there, and you can ask the supplier to change if you want. And as an these are some example, like operation without PV power available, that is we call on grid state. And then you can get the energy from the grid and the battery, and the battery will be discharged until a low defined SOC level. Yeah, I mean, you have to define whether it is 10%, 20%, 40%, or 50%, right? Then the battery will recharge from the grid. That is also available. I mean, whether you can recharge your battery from the grid, or whether you recharge from the battery from the solar, right? It is also depend on the tariff structure, because as assume you are on the night, then during the night the solar is not available, then you can charge your battery from the grid. But at that time, if the peak is there, and if you are on DOU tariff, then you have to get the grid power with the high cost. Then you have to program not to charge during the peak, but charge after maybe 10 p.m. or 11 p.m., something like that, according to your DOU tariff, right? And operation, the second mode, operation on grid with PV power and battery charging. Then energy supply is PV power, then public grid and the battery. And the battery storage will be charged with excess PV power, and afterwards the PV power excess is feed into the public grid. That is also possible. I mean, whether you charge your battery from the solar, or whether you sell, because that is also, I mean, you have to decide. Without charging your battery, even if you can sell and you can earn money, then if you think that that is more economical, then without charging you can sell the solar to the grid and earn. That's why I told you, I mean, if you take a hybrid system, that kind of programming possibility is not available. But for a microgrid, that possibility is there, that you can even change. Today you can assume, okay, we go with that, and maybe after 1 week, if you decide, okay, this is not economical for me, and I have to change, then you can program it and upload it. Then the system will work in a different way, right? Right. Likewise, you have the off-grid state, different modes are available. I'm not going to explain all these things. Then there are so many advantages, right? I mean, promoting the local consumption of renewable energy and improving the ability to resist emergencies and saving power transmission loss. Likewise, there are so many like independency, energy security, eco-friendly, and low noise, and all. There are so many likewise advantages are there. I'm not going to explain all, but I will little bit explain about challenges of microgrids, because even though we want microgrids, I mean, high capital investment is there. I mean, it's a huge, right? And if I take one example from our University of Moratuawan, its total capacity is around 350 kilowatt from the solar, and batteries around 400 kilowatt hour battery, and then we have the diesel generator also with the same capacity, and the total cost is around USD more than USD 1 million. It's huge cost, but I mean that cost maybe you cannot compare with that because it's a pilot project, and there were some consultancies involved in that because as it's the first one, but when you go to the commercial level, maybe the cost may be less than, and highly depend on the supplier for the operational and maintenance requirement. That is also a huge headache. Even nowadays, even I'm facing the issue because they are not giving all these access to us, and they keep everything, and we even those access is not with the local supply, because we have local supply and the foreign supply. Then all these access with the foreign supply. Then whenever you want to change something, and have the send message to the foreign supply, it's a huge problem because it's still our local suppliers are not capable to operate independently without the foreign supply. That's also another issue. But maybe that problem may change in the future because only one first microgrid. Then applications, organizations like wanting low energy cost, they can go if they really want, but an organization require large amount of reliable energy, and organization pursuing sustainability because they have to, I mean, it's not just like a market, like you can calculate like ROI, and just simple ROI calculation, you cannot get it done because it's not feasible, fine. Therefore, you have to, I mean, if you are going to market your product or something, and maybe if you are marketing your company as a sustainable company or something like, then you can add that component also to the microgrid component. Then and only it will, I mean, you can calculate the ROI. Otherwise, it's not feasible. And when it comes to the design, there are so many microgrid design tools are available. Like there are some tools like Homer. So it's only for the microgrid design, and also Cindy and other the DR Camp, and all these softwares are only for the microgrid system design and simulation. And those are like Homer and Cindy I have using. I mean, it's very simple softwares. You can input what are your requirements, then they will calculate and give what are the values of like how much you can use, how diesel generator, how much should be the solar system, how much should be the wind, and all these values given according to your requirement. And there are different types of microgrids. The remote microgrid, that means it's not grid connected to the grid like we have, I think, in the Syria, one microgrid remotely in area that is not connected to the grid. Remote microgrids are there. Then community microgrids, I mean, you can connect different, like several houses together and make a community microgrids, and community microgrids are also available in other countries. And then institutional microgrids like campuses, universities, you can have microgrids. And when it comes to the commercial level, one example of in our country, we can connect like hotel sector. Like we have already started some discussion with hotel sector in the yard area, where because if the hotels are in different places, you cannot connect, right? But if your hotels are in a stretch, then you can connect together all these hotels together and make the one microgrid cluster. Likewise, military bases easily we can do. And this is some pictures from the institutional microgrid, for example, that is funded ECO University microgrid project. And you can see the pictures of this. You can get some idea about the battery size and the container. And then there's a SCADA system. Side you can see, and there you can see whether the system is connected to IDAT and how much energy generated can be seen from the SCADA. And there are community microgrids and military microgrids and commercial and industrial microgrid. Different countries actually they have been doing this as a practice. And these are some example calculations I found from like 175 kilowatts of microgrids cost around 343,000 like USDs, and 1 megawatt like more than 2 million, and 40 kilowatt is a smaller one, it's 28,000, something like that range in the USD cost. And barriers to implement Sri Lanka, like limited available capital, that's a basic problem, and regulatory uncertainty because it's still we don't know. I mean, there is no rules and regulation for the microgrid development within the Sri Lanka, and uncertainty of the utility support because sometimes they support renewable, sometimes they say no. That uncertainty is also there for this industry, and then technical risk is also there. Because although the technology exists today to construct and operate, few are operating, and its operational experience is limited for the microgrids. As I explained previously, we have to depend on the foreign companies. Then high financial risk, that's the biggest. Then how we can go ahead with, what are the proposals? The first one is, what I'm proposing is like establishing a proper regulatory framework is necessary, and for the provide the financial incentives. And the second one, no one can invest for like a microgrid. Then what we are proposing is at least there should be a government-owned company or whatever, like the SPV, like the special purpose vehicle, special purpose vehicles, or special purpose to promote this microgrids, like LECO, something like microgrid private limited or something like that. Right? That company can promote that. Otherwise, it's very difficult to promote this microgrids as it's cost. And then legal assistance is also required. Okay, then I came to the last slides, and we, the University of Morocco, the department, we started doing something for this during this financial crisis, and we have already installed around five to six off-grid systems, and this inverter is developed by our own students, and 10 kilowatt hours microgrid, and not microgrid, off-grid system. And these batteries are basically lead acid batteries you can buy from the local market. Lead acid batteries are only available, and inverter is made by ourselves. Therefore, components we can buy from the markets we can buy. Therefore, we are trying to promote these off-grid systems because it's locally manufactured. If I compare with the actual system in the USDs buy from the market, even we can save around 75% of USDs from this system. But it's still we have installed only the places where we know, because it's still the protections and some issues are there, because it's still we are doing some R&D. But we have already even it's sell. I mean, we can sell these systems to the customers as well. Yeah, with that, I would like to stop my presentation. Thank you very much.
Thank you very much, Professor Udayanga, for the valuable speech and the presentation. Now, let me invite Engineer Kushan Jayasuriya for the second presentation. And let me introduce Engineer Kushan Jayasuriya as well as of this way. Engineer Kushan Jayasuriya hold bachelor and a master degree in engineering from Loughborough University, United Kingdom, and is well-known figure who is involved in solar industry, considered as one of the largest equipment and system integrator importer in Sri Lanka. He is the president of the Solar Industries Association of the Sri Lanka. Engineer Jayasuriya started his career as a graduate process engineer in McLaren Mercedes in UK and subsequently worked as a research associate and development engineer in Loughborough University. At the present, he is a director of Alpha Solar Energy System Private Limited and Alpha Thermal System Private Limited, more known as Solar Therm. He is a member of the Institution of Engineers in Sri Lanka, Chartered Institute of Building Service Engineers in UK, and the Institution of Mechanical Engineers in UK. He has earned his charter from the Institution of Engineers Sri Lanka and from Engineering Council in UK. With over 10 years of solar PV experience, Engineer Jayasuriya acts as a resources person in many solar energy related seminars, workshops specializing in value engineering, designing and implementation of commercial grade solar PV and thermal systems, trained professional engineer for off-grid and off-grid systems by the World Bank. So let me invite Engineer Kushan. Engineer Kushan. Over to you, sir.
Hello, I am Kushan Jayasuriya. I'm also the president of the Solar Industries Association. And thank you very much for coming for this timely seminar, where we are used to talk about grid connected systems, but unfortunately, because of our country's situation, now we have to go back to Stone Age, or rather, it could be the future also, where we use off-grid and also hybrid solutions. As Dr. earlier explained, hybrid has a lot of definitions. So mine could be also different again. So if you talk about off-grid systems, how do I move this? Can someone help me? So, yeah, okay. So off-grid system is the most basic way of utilizing solar power. So basically what we have is, we have a set of solar panels that is connected to a set of batteries using a charge controller, because the voltage and the current of the solar panels will vary depending on the sun's intensity. So basically what it does is charges a battery using the solar panels, and once we have the energy stored in the battery, we have an inverter, because battery is DC power. So for it to be useful, it has to be AC power. We convert it and we sell it. So it's the simplest form of utilizing solar energy. And it's been there in Sri Lanka for almost 20-30 years. There are, I think, thousands and thousands of installations a long time ago on off-grid systems. So its applications are quite evident. If you see a lot of the traffic lights are powered by solar panels. There are a lot of vaccine refrigerators all across the world powered by solar. There are a lot of water pumps, believe it or not, which are powered by off-grid, but most of the water pumps don't have a battery because with the variable frequency technology improving, these water pumps are directly connected to solar panels. So depending on the sun's intensity, the frequency will change and these pumps will operate, but those also basically operate as hybrid, as off-grid solutions. Other portable appliances include your little calculator, little watches and things like that. So the good thing is off-grid system can be implemented anywhere. It's not regulated by anyone. Hopefully Mr. Harsha will not put a regulation now. So you can have your own little battery, you can have your own little inverter, and you can have your own little system. The issue is the cost is high because you have to store energy. So in Sri Lanka, a 200 amp hour battery was around 63,000 about 4 weeks ago. Now it's 100,000. So I think Sri Lanka is going to be even more expensive by the week. And even on a rainy day, battery systems will work. So if you think the solar system will not work on a rainy day, that's a myth. You can actually size the battery so that what we call days of autonomy. If you want to run it for 2 or 3 days without sun, still the batteries can be sized. High initial costs. There's no way of earning profit according to the current system. Limited storage, and obviously it needs a lot of space. It's not the most beautiful thing to have batteries all over your house. So if we go for a off-grid system, there are a lot of factors that we have to consider. Where are we going to feed the solar panels? Is it in the garage? Is it on the roof? Then on all off-grid systems, your kilowatt hours are limited. So don't go and buy a 5 kilowatt inverter expecting that it will run forever. It all depends on the battery. So the load requirement has to be calculated, and there are several ways of connecting DC coupled and AC coupled, which we'll talk later. And how many hours you are going to use this? I mean, if you go to Facebook nowadays, you can buy a little 1 kilowatt inverter, and you can buy a battery, and you have to be very careful not to over discharge this battery and how you are going to use it. And obviously, if you are going to have a rainy day, you have to calculate for that. Otherwise, when there's a rainy day, you have no power and you will be in the dark. So I think most of you are engineers, and there's no point me trying to teach you a lot of theory here. But if you look at your average house, if you want to do an off-grid system, for example, if you have a television that takes 50 watts, if you have one of them, if you run it for 4 hours, it's 200 watt hours. Similarly, you have ceiling fans, water pumps. So you have a table like that. So you can do it on your own. You can have your wattage, which is the instantaneous power, separately. And you have your daily consumption, which is in watt hours. So in this example, let's say it's my house. I need a peak load of 1590 because I have 50 watt, 10 watt, 350, 85 watt, 750 watt, all which can work simultaneously. So I have to make sure that my inverter can give 1590 watts in one instance. But therefore, thereafter we must ensure that if we have a battery system, obviously, which we have, that it is capable of giving the endurance or the longevity for this 1590 watts to operate. So in general, if we just put it multiplied by the numbers and the appliances, we get the watt hours. This is O-level physics. So we need about 3,310 watt hours, which is about 3.3 kilowatt hours. Yeah. So for example, if we want to size an inverter, are we going to buy a 1590 inverter? No, because the inverters have something on their nameplate, but their continuous rating is different. So I always say multiply it by at least 25%. So if you need 1 kilowatt, use 1.25, because at a high loading factor, the inverter is going to be very hot, and you're going to kill the inverter very soon. So if it's 1500, try and use maybe a 2.6 kilowatt inverter. Then you might ask me, what if I use a big inverter, like 5 kilowatt inverter? No, don't do that. Because large inverters have a very high idle current. So if you want 1 kilowatt or 1.5 kilowatts, and you buy a 5 kilowatt inverter because you have a lot of money, that on its idle condition, it's going to absorb a lot of energy just for keeping itself alive. You know, it's like trying to drive a Maruti with a big crane or something like that. So always make sure that the inverter is correctly loaded. Otherwise, you're going to have a lot of idle current, which is energy loss. So battery bank sizing, there are various ways of going it, but for simplicity, I've done a very simple way. Our total kilowatt hour requirement in terms of storage is 3,310 watt hours. If you multiply amp hours by the voltage, you get the watt hours. And in this case, I've used 80%. You can discharge the battery. No, you can't. Don't use 80%. If you are using a lead acid battery, use 50% or AGM. 80% I put if you are rich enough to buy a lithium ion battery, you can discharge it to, they say 100%, but I think 80% you can. So typically, if you have a car battery, for God's sake, don't discharge it more than 50%. You're going to kill the battery very, very soon. Then you get the number of batteries you need. And also, yeah, let me see if I have put days of autonomy here. Yeah, so here I have multiplied it by 2, so that in case we have 2 rainy days, we have oversized the battery so that the battery will not be fully discharged if you have rain. But in Sri Lanka, you don't have 2 days of rain continuously normally, unless it's today and yesterday. But this is just a theory for you to get to understand that when you size a battery, please size for days of autonomy or a rainy day, and you can use your battery system. And this is how you typically size a battery system for off-grid. Now you might wonder, how do I select my solar array? There are various ways of going around, but I've just done a simple way of doing it. So a typical solar panel nowadays will be between 440 watt to about 540, 550 watts. So if I take a 550 watt peak solar panels, we take that, we have we can extract 4 kilowatt hours daily from 1 kilowatt of solar panel. So if it's 550 watts, as a thumb rule, we get about 4 kilowatt hours if you're tilting it to the south. So from each panel, assuming that we have, we can get 4 kilowatt hours from each one, we can get about 2,200 watt hours per day. That's about 2.2 kilowatt hours per day. But from this also, I would suggest you compensate for temperature mismatch and all those, because solar panels, as the temperature goes up, the performance goes down. Actually, honestly speaking, we can get about 5 kilowatt hours, because according to the maps given in Sri Lanka, we have about 5 peak sun hours. So you can actually take it as 5 also, but I've taken 4. But what I'm saying is, please compensate for temperature losses. In Sri Lanka, we will easily lose 15 to 20% for temperature losses from its rated value, because our nominal operating solar panel temperatures can go up to 45, even 50 degrees. So from this, you can identify that you'll need about 2 modules to get your required energy. So I've done what I've done is I've taken from each solar panels how many watt hours we can get, and I've divided the requirement by the output per module, and you need about 2 modules. This is just a cost indication for the system. So I was looking at around 2 kilowatt peak load, 1 point. So an inverter will be about 350,000. If you operate the batteries, you'll need about 340,000 PV modules. 2 modules about 175,000. It keeps on going every day. So for about 1 million, you can get a decent system. I think it's cheap. I just put some high figures. But this is how you do your cost. If you're an engineer, you can actually do your own off-grid system. You don't need a supplier. Just get a good inverter, get some lead acid batteries. Make sure your inverter has a charge controller that supports the solar panel you're going to use, and that's about it. So on a global context, off-grid is also becoming very popular. I think every year gigawatts of off-grid systems are being added to the to the global grid. But what we have to understand is a lot of these off-grid systems are now becoming hybrid systems, which are going to be grid interactive, or which is linked to the grid. So the future is going to be not off-grid; it's going to be on-grid. Yeah. So if you look at hybrid systems coming from the off-grid background, the hybrid system which I would define as a proper hybrid system is something that is grid connected also, because there's no point recharging a battery using solar panels, because once the batteries are fully charged, the panels are just idle. So solar panel will easily take 50% of your investment. And a lot of people I know, they have bought inverters and they have connected those inverters to very expensive sets of solar panels. And once the battery is fully charged, you're just wasting energy. Those solar panels are just idling. So if you want to charge the battery, it's cheaper to charge it from the grid. I never said it, but it is always there. So a hybrid system is, in my view, is something that can charge a battery, which can be used on demand. And once the batteries are fully charged, it doesn't go through the batteries. It'll give this power to the national grid. So if our requirement is say 5 kilowatt hours, after the batteries are charged for 5 kilowatt hours, the inverter will go on to selling more. So it will not go through the battery. The inverter will directly sell power to the national grid. This will support the grid, and this will also have your backup system in place. So the modern hybrid systems combine battery storage, solar panels in one forum, and when there's a need for you can export it or you can store it based on what you want to do. I've seen this in a lot of developed countries where the peak power is so expensive, it makes sense for them to store it. So they program it such a way that during the peak time, they use the battery. And when they can sell it at a higher price for the national grid, sometimes they even sell it from the batteries, or sometimes they just sell it from the solar panels directly to the national grid. So this is going to be the future. Now we are talking about an issue with a peak load in Sri Lanka, where we have to run a lot of expensive generators. But if we have some sort of more to encourage these people to have a battery system and to sell some energy, maybe a few kilowatt hours per household, I think that is workable. Considering the losses the CEP is facing, I think still if we put batteries, it's cheaper. So hybrid systems can be used in residential application. They are used in microgrids. I have done a project in Maldives where the inverter is actually working with a diesel generator. So the inverter and the diesel generator continuously talks through a controller. And the focus is we run the generator in the optimal fuel efficiency, and to support the generator depending on the load, instead of starting another generator where possible, we try and maintain, try and power it through the solar system so that the extra diesel is not used. And the cost per kilowatt hour from solar is cheaper in Maldives when compared to diesel. Just to give you an idea, I think now we spend about 100 rupees generating through diesel power. So I think solar is now one of the cheapest ways the utility is getting electricity. So how to select a hybrid inverter? Similar to off-grid inverter, we need to know what is the continuous power we are getting, maybe the continuous surge power or the instantaneous. Sometimes you need a high load to start pumps like that. The array size, the inverter charging capacity. So most of the hybrid inverters have the capacity to charge the batteries through a diesel generator or through a set of solar arrays. So we need to know what's the maximum current it can tell, how fast it has to be charged, and configuration, whether it's AC coupled or DC coupled, and the rest of it. So the advantage of a hybrid system is you can actually support the national grid during the peak time. So during the peak time, either you can use it from your battery, thereby saving foreign currency, or you can actually start feeding the national grid, which is a very good thing. Issue is initial cost is very high, and battery costs are high. It takes more space. Payback is longer because now you have a battery instead of a grid. And also, you need clear policy. If we are to import a battery, still we have to pay almost 30–40% duty. So those policies have to come into place. So if we are to encourage a lot of hybrid systems in place. So hybrid systems are growing at a faster rate than off-grid systems because these are grid interactive with supporting a lot of countries like Germany. They support hybrid systems. They even encourage you to generate your own power and they pay if you have your own meter for using it because it's cheaper for them to pay for self-consumption than actually improving grid infrastructure. And batteries now last for easily 10 years without a problem if it's proper. So this is an old, I think this is about 10 years old. We decommissioned this system. This is a hybrid system. I think one of the first, where we have a three, I don't know whether the person is showing it, 3 charge controllers. Each charge controller powered about 2 kilowatt of a solar array. So this is powered about 6 kilowatt. The batteries are not shown. I think it's somewhere down. So this system, the priority is it charges the battery. And once the batteries are fully charged, it goes into selling mode. So it's so beautiful. So if you don't use the batteries in case of a power cut, all the energy you get will be given to the grid. And when there's an emergency, these batteries will kick in and give power. So there's no loss of energy like in a off-grid system because it goes into selling mode. I think this slide made a mistake. I think lead acid batteries and AGM batteries are very similar. So ignore my error. They have a very similar number of cycles and very similar depth of discharge. I mean, so typical lead acid battery do not discharge it more than 50%. All of you will buy a battery today or day after tomorrow once you have your power cuts. Don't discharge it more than 50% because you're going to kill the battery. If you discharge it for 50%, you can use it for a couple of years. The AGM battery is basically the sealed battery you have. It's a variant of the lead acid battery. The advantage of the AGM battery or the sealed battery is that it has a lower internal resistance. I think on a lead acid battery, the internal resistance is about 10 to 12%. On a sealed battery, it's about 2%. So you can very quickly charge, very quickly discharge all these batteries. But the issue is if you don't give the ideal current, sealed batteries will fail very fast because lead acid batteries are very tolerant for high currents in terms of charging. But if you do try and mess around with the AGM, you're going to kill it. But AGM batteries, I think this slide is wrong, last longer than sealed batteries when they are correctly used. The number of cycles and everything is similar. I think AGM batteries, I just Google, don't discharge it more than 50%. It depends on the manufacturer. So AGM batteries also can be, because of their low internal resistance, they can be charged faster. So instead of 8 hours, you can charge it within 4 hours, depending on everything. If you go for a lithium-ion battery, the suppliers always claim 100%, but I believe you can discharge it for about 80%. And lithium-ion batteries I've seen working for 8 to 10 years. And a lot of the lithium-ion batteries now, they say they have a lifespan of 50 to 20 years. The issue in the Sri Lankan context is lithium-ion 5 kilowatt battery was around 600,000 about 5 months ago. Now it's 1.2 million. So actually, if you buy a lithium-ion battery, you're actually paying more. So best is you buy a car battery because if you look at the economic cost, you can actually throw away the battery after a couple of years. So that is why everybody is struggling to find car batteries, especially the 150 ampere and 200 ampere car battery. It's virtually impossible to find. And I think the price will, compared to what it was 5 months ago, it's going to double in a couple of weeks. So use your battery wisely, consider the economic costs, and if you want to build a little system, you can do it. There's a lot of material available on the internet. So most of the systems are DC coupled, where the inverter, the solar panels basically give DC power. It charges the battery and from the battery use it in hybrid systems. There are AC coupled systems. I think Doctor explained earlier. I think in the Frunius system, it's capable of giving AC power directly from the solar panels by direct conversion, and it can actually work with another AC, another inverter which is off grid. Because normally on grid inverters always check whether it's a real grid. They check for the impedance, they check for change in voltage, frequency, whatever. Any grid inverter will we'll very quickly know whether it's a real grid or whether it's an artificial grid. But as Dr. explained, in Fronius inverter, you can actually tell it, okay, you have a grid, but the grid is not infinite. You are working with another off-grid inverter, talk to each other, work together. So that is possible. But those are AC coupled systems. I think in larger systems, you get those. But in AC coupled systems, there's 2 stages. So the efficiency is slightly less. So for small cases, 1 to 20 kilowatt, it's always DC powered. But I've seen a lot of grids with AC coupled systems. So if you really fine tune and if you put the settings, the frequencies, the voltage, it works. So in AC coupled systems, normally you reduce the power of the solar system if the system is becoming unstable. So all grid inverters have a facility. I mean, a lot of the Fronius grid inverters also can be used as in microgrids. You can tell them if the voltage parameter is going beyond this threshold, reduce the power proportional. If the frequency is going here and there, varying on the frequency, this is the amount of power you should reduce. This is the, so all those inverters which you get in the market are very, very sophisticated, although they look smart because the electronics technology has improved. Yeah. And also, if you buy a hybrid system these days, if I were you, I would go for 48 volts because the batteries are easier to find. It's cheaper to find. But there are some manufacturers you have to buy batteries of higher voltage for the off-grid inverters. I think Huawei needs more than 55 volts. But the thing is, if you lose a battery, I mean, when you're going to replace it, it's not going to be easy. So always, for a small hybrid system, for a small whole system, please go for multiples of 12, 24, 48. But the advantage of these high voltage batteries are they can be charged very quickly because the current is less, the voltage is high, and they can be discharged very high. So in grid support applications, these are excellent. But if it's for a house, I would say go for the standard voltages. Thank you. I think I covered a bit of overall on a very short period. Thanks for this.
Thank you very much, Engineer Kushan Jayasuriya. It's a very, very valuable and timely, important topic you have presented here. I think it's a very interesting presentation, and we also learned a lot more. And this is a message to our online participants. If you have any questions, you can put that question into the chat box, so we can direct to the respective resources person who will answer you at the discussion. And I'm going to introduce our next resources person, Engineer Harsha Vikramasinghe, who is a chartered mechanical engineer by profession and graduated from University of Moratuwa with a BSc Engineering Honours degree and earned his MBA from University of Colombo. He is focusing on energy policy, energy efficiency, renewable energy development, and project planning, as well as operational efficiency of industries and process. Engineer Harsha contributed for drafting of the national energy policy and strategies of the Sri Lanka as a convener of the National Energy Policy Committee. Also, he is a key contributor to the design of cost-based technology, specific tariffs regime of renewables, effort to introduce net metering concept and enhancement of same to net accounting and net plus schemes. Engineer Harsha is one of the architects of Sri Lanka's Sustainable Energy Authority. He has played many roles as National Project Director, UNDP NAMM Project, UNDP Biomass Project, Intermediate Past President, Sri Lanka Energy Managers Association, leads the National Energy Efficiency Improvement and Conservation Program of Sri Lanka. He also consulting. He is a consultant to the several agencies in India, National Electricity Utility of Kenya, and the Maldives Energy Authority. At present, Engineer Harsha is the Deputy Director General of Sri Lanka Sustainable Energy Authority. So I would invite Engineer Harsha to do the presentation. Over to you, sir.
Good evening, everyone, and so happy to be back in this room after a long while. There was an incident before I came here. The organizers managed to switch my qualification with Prashant, and I certainly wouldn't mind changing my qualification with his father, Mr. Lakshman Jayasuri, but not with him, because he's the one who taught me solar energy, Mr. Lakshman Jayasuri. I'm honored to be here with his son today. So I remember with great gratitude that how his father gave me the ABC of solar energy. So exchanging qualifications and experience with him, I don't mind. Okay. Now back to business, but a lot of trouble I'm in here today because most of the stuff I wanted to share with you already shared by these two gentlemen. So let me try to tell you something extra. So are we new to off-grid electricity in this country? I will. Okay. So we are not at all new to off-grid electricity in the country. Town electrification with diesel generators long time ago, a century ago. Then estate hydropower for mechanical and electrical power in the tea and rubber estates. Then there was a program in 1970s. We were in school at the time. Prashakti Pahan was the name of the program. And it was using a lead acid battery and a electronic ballasted tube light, 2 feet tube light. That was the first kind of off-grid applications in the country. Then we had the energy service delivery, ESD, and rural economic development, renewable energy for rural economic development, RERADE, those two back-to-back World Bank projects. So in that project, solar PV, micro hydro, and gasifier, biomass gasifier things were tested and proven. So it was a very worthwhile experience for the country. So present day, there is island electrification happening in the northern islands, then grid-tied solar rooftop systems, hybrid inverters, and off-grid installations. So many things happening nowadays. So this is a picture from the World Bank website, ESD and grid projects, provision of simple 60 to 40 watt solar panels with 12 volt output and a charge controller and a lead acid automobile battery, sometimes deep cycle battery, and 5-6 DC CFL lamps from Indonesia. The brand name I remember as Sundya, and a black and white television most probably with the DC 12 volt operation capability. And we were thinking of a country where the grid electricity can extend to about 85% of the homes and the remaining 15% to be off-grid. But later, when we were developing the energy policy and strategies of Sri Lanka in 2008, we foresaw that about 92% of the country can be provided with grid electricity. So balance 8% was left for off-grid connections to be realized by 2010. This was our plan at the time to reach 100% electrification by 2012 using the remaining off-grid opportunity. But something else happened and the whole country got grid electricity. But during these earlier days, this is the campaign theme of that program, Government Aligned, funded by the World Bank. And the gentleman addressing the gathering here is Nimal Lakshapati Arabji. He was leading this villager education program before he joined the Sirasa group. He was our spokesperson. And this is the rise and fall of number of connections. At the peak of RERADE project, we had about 136,000 homes electrified through off-grid means. But it's not the sophisticated off-grid electrification we have today. But when the grid electricity was extended to these places, immediately the removals came and there was a large-scale default of two banks, Sarvodaya seeds and LOLC. Each one got a hit of about 1 megawatt each, one megawatt of capacity. Large number of households, they simply stopped paying their due lease rental because they got the grid electricity. So during this time, we conducted an energy survey using Ramanidari of these villages and came out with the electrification level map for Sri Lanka. So you can see these darker places here without grid electricity and the lighter places in the map, these are with electricity. And the 2011 census told us a different story. You can see it almost matched the ELA map of our, the civil strife, the terrorist problem, because these places were not looked after by successive governments. So the rebellion and just like the ELA map, the north and the east was in dark, and the rest of the country was in good electricity. So these things really matter. But finally, the whole country got united, and the whole country is now with grid electricity when grid electricity is available. Earlier, it was 24/7. Unfortunately, no longer. So hybrid technology, although the previous presenters explained it in great detail, it's a wrongfully admitted administered term in my opinion. Originally, the divide was between grid-tied inverters and grid-making inverters. So the grid-tied inverters didn't have oscillator or any ability to generate a sine wave energy. And those days, the other types of inverters, the off-grid inverters are known as grid-making inverters, and it had a either 50 hertz or 60 hertz capability to generate sine wave and power system. So now grid making inverters are, for some strange reason, they are called the hybrid inverters. And actually, hybrid electrification projects are a complex technology product. It is not simply a grid-tied inverter with a battery. So that we have to clear. It must involve at least two energy resources and likely energy storage devices. So this is the ideal kind of a hybrid solution. A solar PV module, a wind turbine generator, a diesel generator, battery backup, everything combined in a central control location, maybe a DC bus or a AC bus to give you uninterrupted electricity. So this is the essence of hybrid technologies, meaning it combines several energy resources. So this is the best example we have in our country, the LYT island in the northern sector. So it was electrified using a ADB financial assistance. Now it is, I think, declared open in 2016 or 17. It's fully operational even now. Ceylon Electricity Board is manning this place, and there were 3 other islands which were to be electrified using the same technology, same source of finances. But unfortunately, our big brother stepped in, and because the contract was awarded to a Chinese contractor, the big brother objected, and the project fell apart. Now they are still in the dark, these 3 islands, and the big brother has promised a 100% grant funding solution to hybrid solution to the 3 islands as well. So if you happen to go that way, please visit this place. It's a beautifully completed and very well operated hybrid energy solution, a truly hybrid energy solution in our country. So wind, solar, and diesel coupled with an energy storage solution. So we come to this era not by accident, but there was careful and very hard work performed by engineers and scientists. So when the chronometry is a buzzword, it simply means monitoring time. So what you used to monitor time, in olden days, you had to depend on a central city location, something like the Big Ben, where you have a large, easily visible clock in the central location in the city. So everyone can look at the Big Ben and know time. But nowadays, what we do, we have a simple Casio electronic watch. Everyone wears it. So this is the way the new world works. But earlier days, no one except the kings and counts and the aristocracy can afford wristwatches because they were so very expensive. But now, even for 35 rupees, even after the dollar crisis, you can buy a wristwatch for 35 rupees. I checked near the Salaka pavement, it's still available at 35 rupees. So, but battery is not changeable. That is the situation. But he offered me 1 year warranty. But how to catch the man after 1 year is a different whole game. So, the typical AC power system, the traditional one, is just like the Big Ben. You have a central power plant giving out energy through a transmission network to all around the country. This is the way it goes, just like the Big Ben. The hybrid solutions, off-grid solutions are very much different. It's like a wristwatch. You have your own energy resource, you have your own storage and the management system, and you can get electricity without depending on anyone else. So that is the beauty of going off-grid. So, but the problem in off-grid is the use of batteries. So I have displayed here various types of batteries. Starting from the left-hand side is the Powerball kind of a solution developed by a company known as Stotera, proudly founded by one of our own Sri Lankans, Mr. Pasitu Pallavala, operating from Scotland. So the Powerball-like solution using lithium iron phosphate, and then he has the other one, the next one, Stotera flow battery. It's a bulky device, but with a phenomenal life cycle of about 25,000 life cycles using flow battery technology. Then we have the car battery, the AGS battery mentioned by Kushan, and the lithium ion battery is the easier to find out. The experimental work I do with is with this famous battery. The number is 18650, which came in the older laptops. It's a circular battery, cylindrical battery, just like the AA pen light battery, but slightly bigger in size, 3.7 volts. But you can have several of these in series to get 48 volts or do whatever you like. But be careful. DC electrocution is very painful than AC electrocution. So anyone who got electrocuted with 230 volts here, raise hands please. Who got electric shock of 230? Not many. I count 2-3 people. So it's 100 times painful to have a 200 volt DC electrocution. I have I had a permanent burn mark in my wrist playing with batteries. So be very careful. It's not the same to understand that. This is the famous Nissan Leaf battery. Do-it-yourself people. There are many more people working outside the main solar industry who are supplying the used Leaf batteries as an energy storage device. Before the crisis, one pack of Leaf car battery, used batteries, was priced at around 100,000 to 125,000, and you had about 25 kilowatt hours of battery capacity. It is not good for automobile application, but it is very good for a standby power application for a home. But now, after the crisis, they have jacked up this price to about 500,000 for the 24 kilowatt hour capacity. So it's very expensive, and we don't know how long it will last because it's already spent a lot of time inside the automobile. So the good news is the electricity prices are going to double at least. So it's good news for the country. Frankly, I'm from the industry. We can't go on like this. We can keep on blaming the rulers, 74 years of rulers, and we have done nothing wrong. We are innocent people. They have done all the wrong. So we can continue this joke forever, or we can try to correct this. If we have to correct this, we have to get the real price for electricity, which is, I was told several values. One guy told me it is 87%, another one said 100%, and the really good news is 325%. Someone told me it is going to be as high as 325%. So with this kind of price increases, solar with batteries can actually become cheaper than wind. That is the good news. So this is the unit cost of electricity as per electricity tariff prevalent in our country today. You can see in the y-axis the cost per unit in rupees, and in the x-axis the amount of electricity you consume per month. So you can see it is below 5 rupees for people who are using 60 units of electricity. And to produce this one, before the crisis, we spent about 25 rupees to get that unit of electricity to that particular home. And every such unit sold by CEB incurred a 20 rupees loss. So the other category, 60 to 90, about 10 rupees, and then a gradual increase like this, and finally reaching about 40% for higher consumers. So this, if double, it's going to appear like this, and it is going to hit our consumers really hard. But I hope there will be relief for the poorer sections of the country, because they simply can't afford this kind of price hikes. But the good news is now, if you take this green color patch here, that is the storage. If the storage cost and the technology improves towards such a level, there's going to be a very large market opening up for off-grid electrification. It will be cheaper for a larger number of people if the trends continue into the future. So this is the untold sad tariff story of our country. So this is the frequency distribution of electricity use. My apologies for producing a graph about 10 years back. History 2014, month of July, is the frequency distribution. So you can see the highest number of consumers, 12% of our domestic customers are from using about 55 units. And the graph is like this. And beyond 200 units, only a tiny fraction. The was viable for only that tiny fraction, about 100,000 households in the country. And when we see the energy use of these, superimposing the same energy used by these communities, you can see there's a gradual shift. The people who are not using very much energy, they are not a burden to the national grid. They don't use their frequencies very low. But again, the 55 unit people, they are consuming a whole lot of energy, about 10-12% of the domestic share. Like that, goes up. But the real sad story is in the revenue. You can see these people bring about 2/3 of the revenue, and about 1/3 of the revenue is brought in by the tiny fraction of 1% people beyond 200 units of electricity. So you can see the imbalance. We have the electricity board is trying to play Robin Hood, robbing from the rich and giving it to the poor people, and this doesn't work anymore because we have to change. But this provided, fortunately for the solar industry, a niche market for about 100,000 homes. And the good news continues. The battery prices are solar prices in the world, they are climbing down, and so are the battery prices, we are told. And even in Sri Lanka, before the crisis, we experienced gradual lowering of prices of system per kilowatt. This y-axis is rupees million per kilowatt prices. So it was about 400,000 in the early days to 2014 for smaller systems, but even for larger systems, it was about 250,000. But in 2018, the black line, you can see it has come even closer to 100,000 per kilowatt. So that is the value of this technology development. And Kushan covered this to a great extent, but I will give you some rules of thumb. Storage required for if you want to see how much storage is required, you simply divide your monthly electricity bill by 30, you get the daily kilowatt hours, and 1 kilowatt hour of capacity is will be something around $150 to $200, the best price you can get. But now it has climbed up, and then we divide the monthly electricity used by 120 to arrive at the solar PV capacity. Then inverter required match the solar generation of 4 kilowatt hours from a kilowatt of capacity. So this is the simple rules of thumb. You can do your own calculation to see whether solar and batteries can give you some consolation. So solar PV and energy storage system inverters are very much expensive than the normal inverters. But Shan can correct me if I'm wrong. Because these things can cater to a higher demand than exporting it to the national grid. So for a 5 kilowatt inverter, simple inverter, we can has the ability to give out 5 kilowatt. But hybrid inverter coupled with the battery, it has the ability to give out more power than 5 kilowatt. It can absorb actually 5 kilowatt solar capacity, but for a brief moment, if you are using an electric kettle or something, a good inverter can provide that higher demand as well. So the battery management system is of paramount importance. Without this, actually, the first set of deep cycle batteries we got for our authority, one of the experiments, we lost very valuable equipment within about 3 months because our battery management system was not programmed properly. Kushan was right on the dot when he said BMS and the management of charge and discharge is the key. So with correct installation and good after-sales support, 20 years of hassle-free electricity can be secured. And most likely no service interruption will take place, but we are yet to see the true colors of the solar PV industry. And we did some calculations with the present prices after the US dollar crisis and everything, and found out very bad news. I gave you good news all the time, but with the latest battery, with the frequent changing of batteries, actual delivered cost to your home is going to be about 200 rupees a kilowatt hour of energy. You can correct me if I'm wrong, but these are the prices I got. And if it is a lithium-ion battery, it is going to be in the same league, about 166 rupees per unit of electricity. after correction to the dollar crisis and the Ukrainian crisis. Everything. Similarly, lithium iron phosphate a little bit lower, 130 rupees per unit, and flow batteries, even though it is not fitting in very nicely in your home, it will be under 100 rupees. So these are the prices. But the good news is, if the solar ESS become a mainstream technology with these assumptions, 250 rupees per dollar, our economy is stabilized again, and solar PV cost falling to 140,000 rupees, and interest rates falling back to 10%, and batteries, the cost falling back to 100 kilo per kilowatt hour, and life extended from 5,000 to 20,000 cycles, we can actually have lithium iron phosphate delivered energy at about 30 rupees, and flow technology can give you actually less than 30 rupees electricity. So this is where I think the future is. So we hope and pray everything will arrive at this nice figure, the assumptions of mine. So then that fine day, all of us will be wearing wristwatches there, looking at the big whale. But one catch, these things are, as Dr. Professor Hemapala correctly mentioned, requires a lot of complex analytics. I'm just showing you, actually showing off the amount of analytical inputs which went into deciding the Suryabala Sangrama, the schemes. So these graphical outputs are from our metrics operations conducted to find out the proper pricing for selling grid electricity from a solar generation. So you can see this is net metering scheme, this is the excess export scheme, and this is the net accounting scheme. People who are familiar with this industry, they know these terms well, and this is the net plus scheme. So we evaluated, and all the purple colored patches mean it is not viable for these people. So size of installation immaterial, 0 to 90 unit people, they are represented here. This axis is monthly electricity use. And a whole lot of people, it is not viable for them. So that is why we expanded this scheme to net accounting and excess export. So there's a subtle difference between these two. But unfortunately, our ministry got in the way, and they thought these two schemes are the same and deleted the most important scheme, which is the real net accounting scheme, and gave the excess export scheme the name net accounting. Now we have three schemes, not this one. So we designed this one to cater to the middle band people who are using 90 to 120 units of electricity. I will take a lot of my time and your time to explain the subtle difference between these two, but unfortunately we lost the middle band, and as a result, all the middle income homes don't have a good program to write on. So because we, as you can see, again the 90 unit people, they are excluded. The purple patch means it is not viable for them. So, but here only 30 to 60, rather 60 unit people put excluded. Everyone else had less than 5 years payback. The darker green patch means people who are using having a less than 5 year payback period. So we wanted to correct it, but unfortunately it didn't happen like that. So the important points to ponder. Already do-it-yourself installations have reached about 2 to 3,000 homes in the country. If you are a avid Facebook user, look for ඉරුවෙලියෙන් විදුලිය ලබා ගැනීමට බලාපොරොත්තු වන්නන්ගේ සංසදය. There is a group of people coming together to work together to get, they exchange ideas, they tip you where to find the leaf battery, and they get together and provide each other solution. No engineers involved, purely civilian movement, just like the Aragale at the Goldface. So major renewable service companies are also gearing up to provide solutions. That's a good sign. And protecting the customer has become a serious issue. Electrical shocks, if it is a grid installation, there are checks and balances, circuit breakers, earth leakage circuit breakers and everything. But in an off-grid installation, you are on your own, you can get electrocuted and get yourself killed. So nobody to take care of you. And there is a serious fire risk with the lithium-ion batteries. I have seen a Toshiba laptop catching fire in Japan, and there was no way we can put that fire out. Usually people say you can get a damp cloth, and when you cover the fire, you can stop the fire. Lithium-ion fires are is still burning. So you have to push it down because a lot of bad emissions coming from the burning lithium-ion battery. There were people who pushed it outside the room, but there's no way you can stop a lithium-ion fire using usual firefighting equipment. Then investment security of people, they will give you 100,000 rupees to have a battery, thinking that it will last 5 years, but unfortunately, it can fail in 6 months, 1 year, we don't know. Then after sale service, if the people vanish after selling with the battery, big problem. Then whether the Kushan prompted me, whether we can regulate this, we certainly can. Section 24 to 28, we have not yet used that provisions in our legislation. We can simply evoke that provision and get these people under regulation. But with the problems we are having with the grid connected regulation, we don't dare do this. We will find it very difficult to regulate thousands and thousands of installations. But definitely there will be a day when someone will sue us for ignoring this community, and one after a electrocution death, this can come up. So my idea is we have to regulate it immediately to avoid large-scale fraud taking place in the country. And also we can wait and see, but I prefer the first one. So the industry architecture will be fully off-grid residences with no grid connection. That is what I think for the future. And we can make these off-grid installations grid connected to allow a dynamic electricity market in the country. I think that they will be very near. And realizing long-term vendor commitment is a very important thing. Changing from product service culture to a service culture, meaning you are not selling a system anymore, but you are getting a monthly pay. If we can convert this industry to something like that, then the vendor commitment will be there. And weeding out the bad response and rewarding the good response is on our agenda. Then we will get rid of the bad people who are in the industry. So these are the thoughts I wanted to share with you. And thank you very much. And have a pleasant day.
Thank you very much, Engineer Harsha Wickramasinghe. Now it's time to start the panel discussion. So I would like to invite Electrical, Electronic and Telecommunication Section Committee Chairman, Engineer Kosala Kamuradiniye, to hold the panel discussion. And in the meantime, audience, you can raise your question to the panel as well. We have many questions from the online, our online teams, online participants. We have already forwarded it to the panel, and also you can ask questions from the panel, so they will answer. Thank you.
Thank you, Sampath. I can give the opportunity to the audience who are here if they have any questions. First opportunity. Yes.
I want to get clarified from Engineer Harsha about the service type of installation, especially for the battery, since it's a highly cost matter. So if the service provider is providing a service type of a battery and we are paying a monthly service fee, and they will look after it for maybe 5 years or 10 years, rather than we purchase off the shelf. Is that kind of a solution can be introduced to Sri Lanka?
Yes, it is very much the desired outcome, because some of these batteries, if mismanaged, can behave very strangely, especially the lead acid versions. If you draw it really hard, more than 50% to be precise, you will actually lose the battery in about 6 months. So whether it is 100,000 or 120,000 doesn't matter, we'll only get that much of energy service. So that is why we insist that it is better if the industry can regroup and offer it as an electricity service company who will come pay a visit every quarter or so, look at the installation, go back. But these things cost money, but that is the only way to achieve the economic benefit to the country. Otherwise, we'll be piling up a lot of batteries in the country and losing a lot of foreign exchange. So that is why we propose a service agreement. But just to give you a clue, even though lithium-ion batteries claim 5,000, 6,000 life cycles, the telecom industry experience is quite contrary to that. It's in the vicinity of 2,000 cycles. So similarly, other batteries also, we have no first-hand experience rather than the LURTV experience. It may be lower than we expect because battery technology is still evolving. But in the future, there will be definitely longer life cycle batteries and investment will be secured. I hope I answered your question. Thank you.
Thank you, Engineer Harsha. So we can allow another question to the audience at headquarters.
Yeah, can I ask from the panel, right? Like as a citizen and a consumer who is going to fall into trouble in the coming weeks with the tariff hike or whatever, where can I, like someone who lives in Colombo suburbs like Kotte with a normal household, 4 or 5 in the family, where can we approach? Well, we can go to any service provider, but what is the best way to approach and get the best solution for us to go off grid? Whatever the best advice, when we by producing our demand, right? What can we do, as a consumer to go on to a very economical solution?
So you're asking about the supplier or the contractor?
Wherever, whether it's a government agency or, where can we get assistance or advice as to what, I think this question will linger in many other citizens' minds also,
I think the best institution is the Sustainable Energy Authority. Harsha will answer that.
Yes, actually, we provide guidance to people who are doing solar rooftop installations. Battery technology is even new to us, so we will not be that useful in our advices, but we can guide you in selecting a good supplier. There are not many of the solution providers in the market, and the people who are in it, they are quite big companies and with years of experience. So it's always better to not to rely on a single supplier, but we can give you a list of suppliers. We can't recommend anyone to you as a government agency, but there are good people out there, and there are some wheeler dealers as well. So unofficially, we can tell you who is who. Officially, we can't.
Okay, I will take one question from the online audience. This question is for Professor Udayanga. He's asking about the microgrids. Are these systems affect the stability of the national grid?
Yeah, I mean, if you take the microgrid in the island mode, then it's already not connected to the grid. Then there is no any issue. But when the system is connected to the grid, it's same as a normal solar system. Assume the microgrid as of the solar system. Then they are feeding the electricity to the grid, right? And if you take a normal solar system, also feeding the electricity to the grid, right? There are issues like, the stability issues and other voltage fluctuations and all other the technical issues are there. But I think as engineers, as I think most of us are electrical engineers are there, we are here to solve that. CV, electricity board is there, right? They are here to, they are to solve those problems. Therefore, I think the problems is there, but it can be solved. Therefore, it's not a big issue because all the theory and all the things are known to us. and other countries already solved those issues. But only thing is, we need to maybe spend some money, right? Investment should be there, right? But those are not issues where we cannot solve. We can. Yes, that's my answer. The problems are there, but we can solve.
Thank you, Professor Danga. So I'll take another question from the online participants. This question is for this question for Kushan. How can we convert a grid-tied system to an off-grid system? And are there any safety concerns in doing that?
Yeah, there's no short answer for this, but if you have an existing grid connected system, you can't convert it to off-grid system. That's the reality. So unless you change your inverter to a hybrid one, which can work with a battery, which does not make economic sense because most of the installations are within a couple of years. So there's no point throwing away that inverter. So the short answer is you can't use the existing off-grid inverter as a on-grid inverter as a solution for off-grid. Now I've seen on the internet that a lot of people have made these switches where they have like a changeover switch where you change the set of solar arrays from the grid connected inverter, and you by putting a switch, you pump it into a off-grid inverter charger. I don't think that's recommended because what we have seen is whenever we have a DC switching, which is happening very regularly on a grid inverter, it ends up burning the power stage of the on-grid inverter, because on-grid inverters are not designed to have their DC power supply connected and disconnected in a live environment very regularly. So if you can avoid it, avoid it. The other one is you're switching almost 800 to 600 volts. So you have to be very careful. If you have a switch, it has to be a properly rated switch. Otherwise, you'll easily catch fire if you try to use normal switches, because normally DC switches are spring loaded. So you have to be very careful in doing so. My suggestion is, if you have a grid system, let it be, don't disturb it. Buy an off-grid inverter with mains battery charging. So whenever you have power, this grid inverter will feed the national grid. I know CB will not like it, but it's cheaper to actually charge it from the national grid to your battery and use it to the night time. If you are rich enough, buy an inverter that has a solar charge controller. So you can maybe connect 2 solar panels to the inverter so that the battery gets charged and you can use it when you want it. The simple solution answer is the existing on-grid inverter cannot be used as an off-grid inverter. Don't try it. Thanks.
Thank you, Engineer Kushan. So I can give another opportunity to the audience here.
Yes. Being a layman, the question is for the panel. Being a layman to the subject, the first question is the sustainable energy. They have a small scale supplying or exporting to grid. Most of the people, there are a lot of people who have been suffered under loan arrangements, but they are not getting the dues from the CEB. Probably now about 6-7 months, most of them have not got their dues and they were got stuck because of their loan issues. So is there any solution for it, or is there any other way? And my second question is more technical, and Kushan probably be able to answer better. Is now when you go searching about the inverters of today availability, there are 2 mode of operands. One is PWM and other one is MPPT. So for Sri Lanka kind of weather pattern and other system, what do you reckon? What is the best methodology or the system that we should choose as a small scale requirement?
I think the first question is that the people have not got paid. So as renewable and as energy associations, we met the PUCSL, the CEP, and also with the banks on a joint forum. So CEB committed that they want to pay us, but they don't have the money. So the reason being that they are selling energy at a lower cost than what they are supposed to. So there is an issue, I think, discussion between PUCSL and CEB as to who is responsible for this mess. But the PUCSL advised the CEB that no matter what, these are signed agreements. So these are legally binding. So it will be a matter of time where people will go to courts and it's going to be a problem. So what CEB assured is that they will somehow maybe talk to the treasury with the PUCSL and find this money. But I think for about 8 to 9 months, some of them have got paid. So a lot of these plants will go offline if it continues to happen. So we have about 1,200 megawatts of privately owned renewable energy being fed to the national grid. So if they are not paid for 1 year, those directors will go to the grid ban, they'll go bankrupt, and there won't be energy industry, and people will not invest on renewable energy also. So it's been taken seriously by the PUCSL. I think they said they're having another round of talks with the authorities. So hopefully that matter will get solved. The second question is in the industry, there are two types of charge controllers. One is the pulse width modulation, and the other one is the maximum power point tracking. So the earlier one was known as the pulse width modulation, where the solar panels operated in a typical voltage parameter of 12 volt and 24 volts. So those old solar panels, 120 watt, 50 watt panels, they operate very close to the battery voltage. So you can connect it to the battery and with a little charge controller, it will bring it to maybe, if it's a 12 volt system, maybe 13 watt or 12.7, it will charge the battery. But there are limitations with the PWM, because in the PWM, your solar panel module voltage is very close to the battery operating voltage, which means your voltage is low. Solar panels earlier days were 12 volts. Now the new panels operate around 44 volts open circuit, but they're or 36 point. So in summary, the limitation with PWM is because they operate at a low voltage, the current is very high. Maximum power point tracking, what it allows is you have an array of solar panels connected in series. So from morning to evening, you will have a wide range of voltage starting from maybe 150 volts to up to about 600 volts. So your charging voltage is about 400 volts. That means, equals IR O levels physics. I think there are more educated people than me here. So you can inject a lot of current into the battery. And also in the maximum power point, it always looks at the highest power the panel can produce. So it has an algorithm, it checks it changes itself and check what is the maximum power this panel can produce, and it will inject it to the battery. So with PWM, maybe maximum you can go about 1 or 2 kilowatts. After that, the current is so high. Imagine you try to charge a 24 volt battery bank, you are talking 80-100 amps trying to work with, and those are huge cables. You'll need like 50 square meter, 100 square meter cables. It could be popular. So with the MPPT, what it does is it allows more flexibility for solar panels to be connected in series. Because once you connect solar panels in parallel, you have to have junction boxes, and you are dealing with huge cables. So if you're buying a system, always go for MPPT, because for PWM chargers, there are no solar panels available, virtually no. Because the modern day 60 cell or 72 cell panels operate in ridiculous voltage, 36 volts, 45 volts. So that means they have to be connected to a device that can accumulate that voltage and make it sensible for so that the battery can be charged. So PWM is cheap. It's very good if you have 1 or 2 panels. Because if you have 1 or 2 panels, you don't have a wide voltage to play around. So best is you just change the voltage, which is very close to the battery, and charge it. But if you have 5, 6, 7 solar panels, each having 36 voltage or 44 volts open circuit, how are you going to connect to the battery? So you have to have a device that will look at all these voltage parameters where the solar panels are connected in series, and then charge the battery in a more efficient way. Yeah.
Thank you, Engineer Kushan. The next question is, I direct this question to Professor Udayanga. Professor Udayanga, when we have an off-grid system, how does the protection operates in a system like earth fall protection? Like that, how it does it operate?
Yeah, now if you look at the off-grid system, even though it's off-grid or grid connected, the earth fault protection should be there, because as we know that if somebody touch the wires or any equipment, then the current will go through the body of the person, right? But if you take the off-grid system, the problem is then your supply. Now, if you take the grid system, because the neutral point of the transformer is earth, and your if you take your house, your earth point is your all the outer I mean the metal surfaces also connected to the earth. Then there is a closed path. That means because as you know, as electrical engineers, to go to I mean when a current pass through a body, that should go through the earth and return to the neutral point of the transformer. But when you take the off-grid system, I mean, if there is no earth, then if somebody touch, then there is no closed path. But even if there is no closed path, because your inverter is maybe connected to the maybe the wall or somewhere, then even though with the high resistance, there can be a closed path. Then even the current can go through the body. Or even in that case, assume there are two persons touch the 2 points of your system, then there can be a circular current. Then even the electrocutions can happen. Therefore, even it's an off-grid system, there should be earthing point. Therefore, even when I showed my our R&D, then we did some experiments, and we have basically in most of the off-grid system, they earth the neutral point, but some I have seen some off-grid system they don't do, because there are some issues. Because once you put the neutral point ground, there will be a voltage build up in the DC side, the battery side. Then you have to protect the battery side. If you have not done, then that advantage is there. Then even if you touch the battery, that voltage will not be there. Therefore, I mean, but anyway, the neutral, my advice is the neutral point should be earth. Then you have to protect your DC side as well. Then. Otherwise, the electrocution can happen. Thank you.
Thank you, Professor Udayanga. So the next question is I think we can take another maximum 2 or 3 questions. Next question is to Harsha, Engineer Harsha. How about SCA approval for the hybrid system? And do we have a tariff regulation related to hybrid installations?
I think there is a standard already approved by the Sri Lanka standards. It was prepared in association with our organization, but I don't have the full information because I come from a different department. I think there are a couple of approved hybrid inverters in the country, just like the other solar inverters. And about the tariff, there had been a submission made to the Cabinet of Ministers. Whether it got passed or not, I'm not sure, because for the last 3 months, we have changed the ministers 4 times. So we have lost track of what is happening in the cabinet. So I have to check that and let you know. Sorry about that.
Thank you, Engineer Harsha. Yes, I will give the opportunity to another question from the audience here.
I understand the government policy of having 70% renewable energy is going to continue up to in 2030. So my question is from Harsha. Harsha, whether is there an action plan to achieve this renewable energy target in 2030, and these off-grid projects might help in getting that target?
It is under development, I must say, because when we looked at the energy policy of the country, which was tabled in the parliament in 2019, we had a vision of going carbon neutral by 2050. So we had a kind of a very loosely connected roadmap towards that position. So it is possible, but whether it is the optimal solution for the country, it remains to be seen, because in such a short notice, if we are to go to 70%, then we need a lot of activity on the ground, meaning the land acquisition is the nightmare in our country. Ours is a very small country and a lot of people in it. You will never believe Australia and Canada, they both have same number of people very close to our number. Even though their countries are so very big, they are about 20 million, 25 million population. But look at our country, just 65,000 square kilometers, and we have 20 million of us here. So getting a piece of land for solar or wind electricity is a very significant problem. So if we don't sort that out, just like the way we sort out these problems in the Mahavali days, we are doomed. We have to know that very well, because the first step in solving a problem is accepting that there is a problem. So we have told this to the series of ministers we had. This is where the real problem is, because each about 1 megawatt of capacity requires about 2 hectares of land. So that's a lot of land. And even for wind energy, even though it is not consuming that much land resources, there are people living in all parts of the country. We don't have Rajasthan desert-like places where thousands of kilometers are without people. So we have to maneuver our wildlife resources, maneuver our people, plantations, agriculture. It's a very, very complex situation. So it's a very tough challenge, but even 100% is possible. 100% renewable. My personal dream is 100% renewable energy.
Thank you, Engineer Harsha. There's another question from the online participants. This is to Engineer Kushan. Question is not very clear. Deep cycle batteries are okay to discharge completely, can go for maximum discharge, I guess, as they are designed specially for solar usage.
I think I also got some personal messages. I think when I said lead acid battery is 50% depth of discharge, I meant the car battery, because when we look at the lead acid batteries in Sri Lanka, they are actually car batteries. So car battery is designed in such a way that the plates are thin. So they are designed to give a very high current for a very short time and not designed to go into heavy depths of discharge. But you can actually get lead acid batteries with thicker plates that can be discharged up to 80%. That is also there. But I didn't go into that detail because in our context, lead acid battery is a typical car battery. Yes, batteries can go up to 80%. As Engineer Harsha said, even the car battery, if you push it to 80%, you can get 200 cycles. So any battery can be pushed into the limits. It depends on the number of cycles you are going to lose by doing so. But lithium-ion batteries, you can push it to almost 80% and still have almost 6,000, 7,000 cycles without any issue. But a battery is a battery. Each time you use it, you reduce lifespan. Good example is you take your iPhone or your mobile phone. When you take it to the dealer, the first thing he does is he enters a passcode and he checks the number of cycles of the battery. The moment he sees more than 500, 600, if you go to Apple, so he says your battery is gone. Because those batteries are also designed for fully discharge of maybe 400, 500 cycles. So the question is, all batteries can be pushed to the limit. The trick with the battery is you always have to monitor the voltage. So if it's a lead acid battery, I don't know if I've said it's correct. I think the moment you pass less than 11.7 volts, you're killing the car battery. That means you're touching 70% of your depth of discharge. But lithium-ion batteries, they don't lose much of voltage. So you have to be very careful when you're using them. You should not just draw 100% because they can operate even at low depth of discharge in a very stable voltage. So if you want to discharge 80%, don't buy a car battery. Don't buy a lead acid battery. Just go for a lithium-ion battery. It's an economic choice. Now, a person asked me, that there's a battery for 200,000 that can go deep. That is a
Thank you, Engineer Kushan. So I can take only 2 questions because there are so many questions. I think but the time doesn't permit to answer all these questions. What we will do is we will take last 2 questions, one from the audience and one from the online participants, and rest of the questions we will post our answers to the web actually. So yes, from the audience, we can allow you.
Solar system installation, investment and the return of the investment with the maintenance. What is the like a 5-year plan, 10-year plan? Can we recover the investment cost? The first question. Another one is the roof inbuilt. Actually, I have seen the roof inbuilt solar system, like a solar panel could be the roof. Can you explain something like that?
First question I'll answer. The others, I think Dr. Pala can answer. I think the first question was the payback. Rooftop solar had a payback of, I would say, 5 years, because we were charged 45 rupees. So it made sense for us to generate our own. But with the present dollar rates, the payback is about 9 years, 8 to 9 years. So unless they increase the tariff rate to a realistic figure, there's no payback at the moment, unfortunately. For industrial customers also, because it's large scale, we still had a payback of around 5 years, which is 4 to 5 years. But now our money is depreciating and we are getting only 22 rupees for the 7 years. After that, it's 15.5. So Sri Lankan rupee has virtually no value for an investor. So what we are hoping and pray, is that the CB will charge the right price, first of all, so that the solar can also compete with them. Because right now it's so subsidized that CB is selling power at a ridiculously loss-making way that any other renewable energy source can't compete. And at the end of the day, people will have to end up paying indirectly. If you can imagine, the cost of CB production was around, I think 18, 19 average cost sometime back, but now it's about 50 because of the fuel prices and coal prices. I think it's now some 200 something. So for solar energy has to be viable, then it has to compete with a realistic tariff. But what we see is that the electricity costs will definitely go up, maybe 2-fold or 3-fold. Then obviously it will have a paper. I'm not saying advocating that it should go high, but I'm saying it should be the right price. So then solar will have a payback. And also we have requested the Sustainability Authority to increase our solar tariff from some 22 and 15.5, which we can't do anything, to at least 45 rupees, which Mr. Harsha is working on it. Hopefully he'll get it for us. The other question, I think maybe Dr. Park can answer on, what was the question?
Can you repeat your second question?
Yeah, okay. Actually, the solar systems, even I have seen, I mean, the ones used for the roofs, right? And not even roof, even I have seen some countries, they have used even for the walls, some buildings in wall, they have put a place solar panels. Yes, it can be, but it's a matter of investments and whether it is viable for us, right? I mean, and the technology is available in other countries. I mean, we are not manufacturing anyway solar panels, right? Therefore, technology is available. Yes, we can do that, but the only problem is the investments. Yes.
One minor correction, there is a manufacturer local. He's operating from Jaffna. Ecos Team is the name of the company. He's making solar roof tiles. So, and there are very aesthetically pleasing building products available with PV capability, but these are very, very expensive, absolutely expensive. Very high-end application, maybe a palace, a place of worship you can afford, but not in a home. Currently, that is the situation.
Thank you very much. So there's another question, but it is already answered by Professor Udayanga. But the question is, most of the time RCCB is not functioning with off-grid inverter. What is the solution for this issue? I think Professor Udayanga answered that one. If you don't have a proper earth, RCCB won't operate because there's no loop to operate that one. So with that one, I think we have come to an end of this question and answer session. As I mentioned, the rest of the question we will try to answer and we will post it to the ISL website. So we'll be able to get answers for your questions. Thank you very much. Sampath, it's over to you.
Engineer Kosala, Chairman of Electrical, Electronic and Telecommunication Engineering Section Committee, for moderating the panel discussion. And it's time to give my vote of thanks to the event participants. So, firstly, my sincere thankfulness goes to Professor Udayanga Henapala, Engineer Harsha Vikramasinghe, and Engineer Kushan Jayasuriya for spending their valuable time and sharing their knowledge with us in spite of their busy schedules. I have no doubts that it helped a lot to all of us who are keen on the subject matter than ever in the energy crisis situation that present in the country. Thank you again for your kind contribution. Secondly, I must thankful to the audience at the IESL headquarters and also those who participated to Zoom platform for their valuable time and participate in this seminar. Without you, this wouldn't have been success, and I hope this event was a fruitful event for you all. And there were nearly 500 online participants, which is very encouraging today. And I apologize from the online audience of at the beginning they had the difficulty of audio and video. It's because the internet service providers link had a breakdown and we had to use backup line which has a limited bandwidth. And again, I apologize for the inconvenience. But the good news is that the complete recording will be available a few days after if you visit to the IESL website. And then I must greatly appreciate Engineer Kosala Kamburadeni, Chairman of Electrical, Electronic and Telecommunication Section Committee of the IESL for his great contribution, not only for coordinating with resources person to moderate the event today, but also for the support given throughout this program. And finally, to the audience who are with us in the auditorium today. And this is the end of this session. I wish you all pleasant evening. And again, thank you very much for participating in this event. Thank you and good night.